I'm fine with this topic, but not so sold on this slide. I do not like spiders. I'm working on it, but we could say for spiders that actually one spider is equal to 8 legs. There are 8 legs in one spider. So if you have 26 spiders crawling on your head, oh my gosh, so maybe some people would like that. There's my frowny face. How many legs would you have? Well, you're probably just going to take 26 times 8, aren't you? But that relationship up here, remember we can take any equality like that and make it into a conversion factor. So if we make our first term the 26 spiders over 1, okay, then we can actually use that ratio as conversion factor. We've been talking about this, how now if we put this over 1, units of spiders cancel, we're left with legs, which yeah, is simply taking 26 times 8. But this is setting it up using the factor label approach, letting things cancel. So 208 legs, oh yikes, would be what you have on you if you have 26 spiders crawling on you. You're like, what does that have to do with anything? Well, this is what it has to do with. Now we're switching from spiders to molecules. Specifically, we're dealing with the compound CBr4. If we read this, let's kind of draw what it's saying. Okay, how many moles of bromine? Okay, so over here on the far right, I'm going to put question mark, moles, bromine. Now I didn't want moles of bromine, excuse me, I didn't want moles of compound of CBr4, I just wanted individual moles of individual bromine atoms. Are there in 1.92 grams of CBr4? Well, we can go from grams of CBr4 to moles of CBr4. What would we use for that? We would use the molar mass. That's what we've been talking about. So we can use the molar mass to get from grams to moles there. And actually, I'm going to show you on the next slide, but just kind of give you a precursor. It's sort of like the spider. The spider has 8 legs. Well, this molecule has 4 bromine atoms. So we could say that one mole of CBr4 is equal to 4 moles of Br. That's it. Okay, and the next slide is going to basically tell you that same thing. And where did the 4 come from? Well, the 4 came from the formula, right? So like I said, you have to read it carefully. We want to go all the way to moles of bromine atoms. We don't want just moles of CBr4. So like I said before, and I kind of broke it down all the way to moles, but we could say in one molecule there are 4 bromine atoms and 1 carbon atom. We get that from the formula, 1 molecule of CBr4. We can scale that up into moles, and we can say 4 moles of bromine atoms is equal to 1 mole of CBr4, or 1 mole of carbon. Okay, very good. Looks like I'm not sure my slide. Boy, I've got another mistake in here. I'm kind of thinking, well, I guess it's the same thing. In 1 mole of CBr4, we have 4 moles of bromine atoms. There we go. So let's go ahead and work a problem. We're going to stick with the compound CBr4, and we're actually going to use that relationship in a problem. Actually, we're going to work the problem that was on the slide, the previous slide. So like I said, we're going to use the molar mass to go from grams of CBr4 to moles of CBr4. You always have to show this, show this, show this. Yeah, I'll put it in the form of a question. Will you lose points if you do not show? Will you lose points if you do not show this? Yes, you will lose points. So show the molar mass calculation. Feel free to label it. I like labeling my stuff. Okay, so we're going to round to 2 decimals. And we get a molar mass of 331.61 grams per mole. Again, what I'm going to be looking for you to use this number is to basically take those units and recognize that's grams over mole. That's what that slash means. Specifically in this case, 331.61 grams over 1 mole. Okay? All right, so what's our first term going to be? It's going to be that mass of CBr4 over 1. Oops, here's my, I forgot I did this. So kind of what I said, we're going to go from grams of CBr4 to moles of CBr4 using the molar mass. And then we're going to go from moles of CBr4 to moles of Br using this relationship. Well, using, dun dun dun, 1 mole of CBr4 is equal to 4 moles of Br. There you go. All right, so here we go. Yep, the first term is going to be the mass of CBr4 we want to convert. I would usually put that over 1. What does the next term look like, the molar mass term? Since we want grams to cancel, we're going to put that 331.61 grams on the bottom of CBr4, 1 mole of CBr4 on top. Now, let's see what you think what that last term is going to look like. We want moles of CBr4 to cancel. We'll be left with moles of Br. It would look like this. With 1 mole of CBr4 on the bottom, 4 moles of Br on the top. Now everything has canceled except for our moles of bromine, which is exactly what we want to be left with. Voila! It's a wonderful thing. Let's go ahead and take a look how we're going to round this. Is there uncertainty brought here? Yes. How many sig figs? I get 3. Is there uncertainty brought by the molar mass? Yes, always. How many sig figs? Count them up. I get 5 sig figs. Is there any uncertainty brought by this relationship? No, no uncertainty. It's what we call exact. So how do we need to round our answer? I'm liking 3 sig figs. So 3 sig figs, and I get 0.0. Remember that first 0 is just a placeholder. 0.0232 moles of bromine. Very good. Okay. So here's my, and this could apply for any problem that you're working in physical science or chemistry, whatever. Sometimes you need to be very careful with your units and make sure that you give enough information with your units for it to make sense. Okay, so that's just kind of a general warning. So let's work one more problem, and it's kind of related to what we worked before. So in this case, how many grams of carbon, let's go ahead and diagram it out, question mark grams of carbon are there in 1.92 grams of butane? Hey, that sounds familiar. Didn't we just do this? 1.192 grams. All right, so we can take that mass of compound, and you know we can get to moles of compound, moles of C4H10. What do we do to do that? Well, we would use the molar mass of the compound. And then we can, now we know we can get from moles of the compound to moles of individual carbon atoms. How do we do that? I guess it was a different compound before, sorry. Well, in this case, from the formula, we know that 1 mole of the formula, C4H10, is equal to how many moles of carbon? The answer there is 4. Yep. So we can use that to get to moles of carbon. Now, this kind of goes back to kind of what we did with atoms before. How do we go from moles of carbon to grams of carbon? Simply the molar mass of carbon, which that's that 12.01 grams per mole right there. Phew! Let's execute. So the molar mass of this compound, we need to account for our carbon, which is the first term, and our hydrogen, which is the second term. And round to 2 decimals, I get 58.12 grams per mole. Again, I would unpack that. Not going to do it now, but I think you're okay with that. We're ready to work the problem. This kind of just says what I said a minute ago. You're okay with all that? So the first term is going to be the mass we want to convert, which is that 1.92 grams of C4H10 over 1. I guess it does make a difference. I think what I meant to say a few slides ago is you have to keep your wits about you. Is this the grams of carbon or is this the grams of C4H10? And of course it's the grams of C4H10. You have more than 1 gram in this problem. I would probably put that over 1. What's the next term look like? Well, since we want grams to cancel, we're going to use what I call the flipped version of the molar mass, which is 1 mole of C4H10 over 58.12 grams of C4H10. And yes, if I was working this problem, I would take the time to write out the formula of the compound. So now we are ready to, our grams have canceled, we're left with moles of C4H10. Now we're ready to go to the moles of carbon. What does that look like? Well, I'm going to put moles of C4H10 on the bottom, 1 mole of C4H10 on the bottom. I'll put 4 moles of carbon on top. Now my moles of compound have canceled. I'm left with moles of carbon. Whoo-wee! And I kind of rattled it off, but if you look at the periodic table, the molar mass for carbon is 12.01 grams of carbon per 1 mole of carbon. So how are we going to use that to go ahead and go from moles to grams? Like it's the non-flipped version, right? Just simply 12.01 grams of carbon over 1 mole of carbon. Moles of carbon cancel, and we are ready to load this in our calculator and round. So is there uncertainty brought by this term? Yes. How many sig figs? 3. Uncertainty brought by molar mass? Yes. Sig figs? I get 4. Uncertainty brought by the 1 or the 4? Nope. Exact relationship. Uncertainty brought by this molar mass? Yes. How many sig figs? I get 4. So again, we're always conservative, so we're going to round to just 3 sig figs. Drum roll, please. And I get 1.59 grams of carbon. So these are the problems now associated with what we just did. Let's see. I want to emphasize, remember I said you have to show your molar mass calculations to get all credit. And what I try to do on my tests, especially ones where, well, I try to say that you have to show all of your work. You must show all of your work to get full credit. And part of your work is the molar mass calculation. I haven't said it yet, but let me tell you that you need to show your molar mass calculations, because if you make a mistake in there, then I can actually see where your mistake was. So it helps you and helps me.